This is A2Pure Maths, and we're on Unit 7, and we're looking then at numerical methods. So first of all, finding roots. So we have to finding roots if f of x equals 0. The root of an equation can be found when y equals 0. So we know there's a root of an equation anytime effectively y is 0, and that's whenever then it touches the x-axis. So here are roots here. Here's 1, 2, 3, 4, 5, and 6. So 6 different roots in of this equation. The values of y for points on the graph, y equals f of x, change sign from positive to negative or negative to positive as the curve crosses the x-axis at b, d, f, a, c and e respectively. This happens when the graph passes through a root of the equation f of x equals 0 as y equals 0 on the x-axis. If you can find two values of x, one for which f of x is positive and one for which f of x is negative, then you know that the curve of y equals f of x must have crossed the x-axis and so must have passed through the root of the equation f of x equals 0. In general, if f of x1 and f of x2 are two different values of x, then if f of x1 is greater than 0 and f of x2 is less than 0, or f of x1 is less than 0 and f of x2 is greater than 0, then a root lies between x equals 1 and x equals 2. It's quite a complicated way of saying it, but effectively, if say you have an equation of a curve or something like that, and you put in a number and you get out a positive number, and then you put in another number and you get out a negative number, that means there must be a root in between those 2 points. Because if it's crossed from a positive to a negative, then it must have crossed the x-axis, so there must be a root in between those 2 points. Let's take a wee look at a couple of examples, and that'll hopefully then. Okay, so example 1 then, show that 3 plus 4x minus x to the power of 4 equals 0 has a root somewhere between x equals 1 and x equals 2. So here's what we do. We go f of x is equal to 3 plus 4x minus x to the power of 4. Then f of 1 is going to be 3 plus 4 minus 1, which is 6. And f of 2 is equal to 3 plus 8 minus, so it's then 2 to the power of 4, so it's minus 16. And that then is minus 5. And simply because of the fact of this being a positive number and this being a negative number, therefore there must be a root between x equals 1 and x equals 2. Example 2. Show that ln 1 plus x equals e to the minus x plus 1 has a root near x equals 2. So I'm going to then let f of x equal ln 1 plus x minus e to the minus x minus 1. That's effectively putting that equal to 0, and then we're going to substitute in some numbers. So obviously we're going to try 2. So f of 2 is going to be ln 1 plus 2 is 3 minus e to the minus 2 minus 1. So hopefully you can see this in the calculator. My light's not great unfortunately, so it's ln 3, take away e to the minus 2 minus 1, and we get minus 0.0367. Minus 0.0367, so that bodes well, it's quite close to 0. Let's try f of 1. So then that's going to be ln 2 minus e to the minus 1 minus 1. And if that's positive, then we're good. There must be a root in between 2 and 1, which means then that we're close. So ln2 minus e to the minus 1 minus 1. Right, so that's no good, so that's getting smaller, so that's minus 0.675. So we try then the other side of 2, so we're going to try then f of 3. So that's going to be ln4, take away e to the minus 3 minus 1. And sure enough, you can take my word for it, but if you put that in the calculator, you're going to get 0.3365. So if you want to write them as f of 2 is less than 0 and f of 3 is greater than 0, then there is a root near x equals 2.